Infinity Labs, an open education initiative. Welcome back to our video series on solid programming principles. In this video, we'll be focusing on the open-closed principle, which is an important concept in object-oriented programming. We'll be discussing what the open-closed principle is, the benefits of using it, and how to apply it in your code. By the end of this video, you'll have a good understanding of how the open-closed principle can make your code more flexible and easier to maintain. Open-closed.
The open-closed principle is a principle of object-oriented programming that states that classes should be open for extension but closed for modification. In other words, a class should be designed in such a way that it can be extended to add new functionality without modifying the existing code. This principle promotes the creation of robust and flexible software systems that are easier to maintain and modify over time. The open-closed principle promotes software design that is more flexible and easily maintainable by allowing for new features to be added through extension rather than modification of existing code. It reduces the risk of introducing bugs and errors when making changes to existing code. It makes the code more modular and decoupled, which improves maintainability and scalability. It promotes the reuse of existing code, which saves development time and effort. It encourages the creation of clear and well-defined interfaces, which makes it easier to work with the code. It promotes better separation of concerns, which makes the code easier to reason about and test. To use the open-closed principle, you should use abstractions to define interfaces and functionality that can be extended by subclasses. Use inheritance and composition to create new classes that implement the abstractions. Avoid modifying existing code when adding new functionality. Use dependency injection to provide dependencies to classes rather than hard coding them. Use design patterns such as the strategy pattern to allow for different behaviors without modifying existing code.
Join us in the next section to put your knowledge of the open-closed principle into practice with a hands-on coding example.
In this example, we have a shape class that defines an interface for calculating the area of a shape. We also have two subclasses, circle and rectangle, that implement the area method to calculate the area of their respective shapes. We can create new shapes by creating new subclasses of the shape class and implementing the area method. The existing code does not need to be modified in order to support these new shapes. This allows us to extend the functionality of the program without changing the existing code, which is the essence of the open-closed principle. The example creates two shapes, a circle and a rectangle, and calculates their total area. The open-closed principle is demonstrated because we can easily add new shapes without modifying the existing code, making the program more flexible and adaptable to change. The open-closed principle is an important design principle that emphasizes the importance of creating software components that are open for extension but closed for modification. By adhering to this principle, software developers can create more maintainable, flexible, and scalable code that is less prone to errors and bugs.